Good morning, everyone. My name is Jatin Kadam, and my teammates are Vishnu Jai and Geetanjali Jadhav. Today, we are going to perform an experiment on Computational Lab 1. The aim of the experiment is to explore VPN security using Cisco Packet Tracer. So, let's see what is VPN. A VPN is a virtual private network which gives you online privacy and anonymity by creating a private network from a public internet connection. VPN masks your IP address so your online actions are virtually untraceable. Most important, VPN services establish secure and encrypted connections to provide greater privacy than even a secured Wi-Fi hotspot. A virtual private network connection allows users to access, send, and receive data to and from a private network by means of going through a public or shared network as the network as the internet, but still ensuring secure connections to an underlying network infrastructure to protect the private network and its resources. A VPN tunnel establishes a private network that can send data securely using encryption and authentication. Mostly corporate also uses VPN connections. Next, as we have seen what is VPN, so why do we need a VPN service? Surfing the web or transacting on a unsecured Wi-Fi network means you could be exposing your private information and browsing habits. That's why a virtual private network, better known as VPN, should be a must for anyone concerned about their online security and privacy. Think about all the times you have been on the go reading emails while in a line at the coffee shop, or checking your bank account while waiting at doctor's office. Unless you are logged into a private Wi-Fi network that requires a password, any data transmitted during online sessions could be vulnerable to eavesdropping by strangers using the same network. The encryption and anonymity that VPN provides helps protect your online activities, sending emails, or paying bills. VPNs also helps keep your web browsing anonymous. How a VPN protects your IP address and privacy. VPN essentially creates a data tunnel between your local network and a exit node in another location, which could be thousands of miles away, making it seem as if you are in another place. This benefit allows online freedom or the ability to access your favorite apps and websites on the go. VPN use encryption to scramble data when it is sent over a Wi-Fi network. Encryption makes the data unreadable. Data security is especially important when using a public Wi-Fi network because it prevents anyone else on the network from eavesdropping on your internet activity. Next slide will be continued by Vishnu.
VPN VPN privacy. What does a VPN hide? Your browsing history, your IP address and location, your location for streaming, your devices, your web activity to maintain internet freedom. Benefits of using a VPN connection. Using a VPN connection helps protect confidential network data and resources, provides convenience and accessibility for remote workers or corporate employees since they will be able to easily access the main office without having a physical presence and yet still maintain the security of private network and its resources as it is like normally used or basically it is mostly used nowadays since lockdown. Adding new users or groups of users to the network is easy since VPN are very adjustable. It is possible to make the network grow without the need for additional new components or complicated configurations. Risks of using VPN connection. Security risk due to misconfiguration, reliability, security issues for mobile devices, slow connection speed, and data leaks. Thank you. We'll just move on with the demonstration now. Uh, uh, like I would show how would you download the Cisco Packet Tracer. You can just go to the search bar on the Google, type in Cisco Packet Tracer download, and you can just download it on the official website, or you can download it on many of the third-party apps that are providing it. And let's move on to the work. And since we saw the topology consists of two end PCs and three 18141 routers. We'll just set up it. These are one, two, and just connect them. Here we are doing the port connections between the router and the PCs. So these are some normal Ethernet connections. And now we'll just move on with the configuration of these routers. We'll first configure the router 0. Mm, yes, enable. Just a second. We'll configure it. We'll go into the configuration mode. Uh, with command config t. Yes. Then we'll change the host name to host r1. Then we'll interface the 00 port. We're into the interface mode now. We'll add a IP to the port 2.168.1.1 and subnet mask 255 or 192.168. No shut. Set. And now we'll configure interface the 01 port. Okay. Now IP add 0.0. Subnet mask 255.0.0. No shut. Yeah, so we have successfully configured the router 0. As you can see, it has become green. We'll just configure the router 2. Enable. We'll just first enable. All of the routers can be configured with the same steps. I just put in the wrong spelling for enable. I'll just correct it. no problem. We'll just uh, configure router 2 by this time. So now we'll just go enable and then config R3 interface FA00 and then IP address and 2.0.0.2 and 255.0.0.0. No shut. That's it. We'll interface again FA01 01 then IP add 92.168.2.1. Okay, then subnet mask of 255.0. Yeah, no shut. Okay, successfully configured the router 2 as well. Enable okay the configuration mode. Let's config T, then host interface 00 right IP address 1.0.0.2 then 255.0. No shut. Set int FA01 IP add 2.0.1 255.0.0.0 and again no shut. Okay, so we have successfully configured all the routers. Now we'll set up the route. Since we have to create a tunnel between router 0 and router 2, so we'll configure the routing settings. Set IP route 0.0.0. This is the first IP is the will be the packet source and destination, and last is the hop. Basically, it is said hop through which the packet will be flowing. The route for router 3. Big IP route 0. Right. Yeah. Then we'll just ping and check if the routing is properly working. Ping 2.0.0.2. Okay, now yeah, there is 60% uh, success rate. Now I'll ping the route to set ping ping 1.0.0.1. Yeah, we have got the 100% success rate, and once we try again over here, uh, here we get the 100%. Now we'll create a VPN tunnel between these both routing paths. We initiate the tunnel over the router 0. We will interface the tunnel. Interface tunnel. Here I'm taking the tunnel number 10. You can take any number. Any number can be used, but make sure the or you can only use the one tunnel at a time. Like if you again configure the same tunnel, it would override the first tunnel. We have given the IP to the tunnel. Now we'll give the source and destination. Tunnel source is FA01. As you can see, it is originating from like router 0 FA01 port, and destination would be the router 2 IP address. Tunnel destination uh, is 2.0.0.2. Yeah, so done. We have successfully created the tunnel. Now we'll create the tunnel for router 2. uh, Config mode, then interface tunnel. I've, I'm taking here tunnel number 100. IP address 172.16.1.2, and then 255.255. 0.0 is subnet mask. Okay, now we'll give the tunnel source. Tunnel source is FA00 port of route 2. Yes. Now tunnel destination. Tunnel destination is IP address. Oh shit. Okay, so we have successfully configured the both the like successfully configured the tunnel. Now we'll just ping them and check if both works. Set 172.16.1. Here we are pinging the IP address of the tunnel. Mm, okay, yes, we have got the 60%, and yes, we got the 100% again. We'll ping such. We'll like check from R3 side as well, or router 3 as well. Ping 172.16.1. Okay, yeah, we have got it finally. Uh, Now we'll give the routing to the VPN. So fig fig now IP route 92.168. We are basically now connecting the PCs, like routing the PCs with the VPN. 5.255.0.172.16.1.2. Okay, is it right? R1 192.168.2 255.2. Yeah, that's right. 192.168 1.0, then 255.255, 172.16.1. Route route. Yes, we have successfully done, and now let's just test the VPN now. Exit. Mm, Show interface. So tunnel. So here we get all the details about tunnel 10. Uh, the hardware is tunnel, internet address, the IP address of the tunnel, and then all of the tunnel source is here, destination is here, then protocol that is it is using is GRE IP, and yeah, then bandwidth and receiver and all of that thing. In the same way, we can do for this as well, router 2 as well. Show interface. Show interfaces, tunnel 100. Here we get the details of tunnel 100. Here the hardware tunnel, the IP address of the tunnel, then encapsulation tunnel, loopback not set, then source, destination, then the protocol again, what it is using, and all of that thing. Now we'll first configure the PCs. We have not configured the PCs yet. Desktop IP address. Configure it first. Just a second. IP address. Okay, so IP address of the PC is PC0. Yeah, IP address of the PC0 is 192.168.1.2. Yes, subnet mask. Yes, and the default gateway. Default gateway means the first gateway to the network. Basically, for the PC0, the first gateway, first network would be FE00 port. So the FE00 port will be the uh, gateway for the default gateway for the PC0. It is 192.168.1.1. Okay, we have configured it. Yeah, we have configured it. Let's now configure the PC2 desktop IP configuration. IP address is 192.168.2.2. This gateway here is 192.168.2.1. Okay, we have configured it. Now let's go to the command prompt and IP ipconfig. Here we can see we have given the configuration, and it shows now we'll ping the other uh, PC. Ping, what was it? Just a second. Okay. Okay, the ping 192.168.2.2, that is PC1. See, request timeout. Okay, we are getting it approximately. Now we'll again ping it. Yeah, now we are getting a 100% result. All the packets are being successfully sent. Now we'll check with the PC1. Ping 92.168.1.2. Okay. Yeah, we are getting all the packets. Reply for all the packets. We are getting the 100% result. So here basically what we did is we created topology, then we created a IP route between the router 0 and the router 1. What happens is when we create a VPN between router 0 and router 2, sorry, router 0 and router 2, the packet is being sent through router 1, but since it is a VPN, the packet is encrypted. Router 1 does not know what the packet has been sent and what is the information into the packet. So basically uh, it is not like it is directly been sent from 0 to 2. It is going through router 1, but router 1 does not know what the packet is. Yeah, thank you. So this was it.